Hello students, let us calculate the Fourier transform of Signum function. So Signum function is defined, its value is 1 when t is greater than 0, and when t is less than 0, its value is minus 1, and t is equal to 0, its value is 0. We can take average of these two values. So here the value is 0. Now we want to find the Fourier transform. So the Fourier transform this function cannot be find directly. So what we can do, we can write this function, okay, this function as a sum of, I can write my sigma t function as a sum of ut minus u minus t. I can write this function as like this, where ut is what? Ut is step function. Ut is a step function. Ut value is when t is greater than 0, his value is 1, otherwise it is 0. Similarly, if I do u minus t, these are called heavy side step function. Means ut means positive side has a step, and minus means you have a step here t, and it has a u minus t. So you have a value 1 when t is negative. Now, if t is positive, this is 0, and you have value, this function has a value 1. Okay. Similarly, if t is 0, this function has a value 1, and this function is also has a value minus also 1. So 1 minus 1, that becomes 0. Okay. And if t is less than 0, then this function has the value 0, and this function has the value 1, so this become minus 1. So I can write my signum function as sum of ut minus u minus t. Now further, we don't know still what is the Fourier transform of ut. So we can also write this signum function as sgn sgn t. I can write as a limit a tends to 0, and then I can write here e minus at ut, and this we have already solved, minus e at u minus t, and when a tends to 0, again this become Signum function. So now let us calculate the Fourier transform of Signum function. Fourier transform of Signum function. So fw, okay, and this is equal to what? This is equal to Fourier transform of limit a tends to 0, e minus at ut minus e at u minus t, and limit a tends to 0. This has a value, Fourier transform of this is value, we have already seen this is value has alpha plus iota omega, and this has a value alpha minus iota omega. And now if you put alpha, means here you have a instead of alpha you have a here, so you have a here. So 1 plus a plus iota omega, and then you have a minus iota omega, and then if you put a tends to 0, this becomes 1 upon root pi. Of course 1 upon root 2 pi is there, 1 upon root 2 pi factor is there, 1 upon root 2 pi. So this become 1 upon root 2 pi. You put a 0, this become 2 upon iota omega. So this is the Fourier transform of Signum function. Signum t. I'll use this signum function while I will calculate the value of full transform step function. Okay, I'll stop here. Thank you.